Endocrinology Minutes with Cyan. Hormones of Mineral Metabolism. Roles of the mineral ions. Calcium and phosphorus are the principal constituents of bone, and together they compose 65% of its weight. Bone, in return, contains nearly all of the calcium and phosphorus and over half of the magnesium in the human body. Organic phosphate is a key component of virtually all classes of structural, informational, and effector molecules that are essential for normal genetic, developmental, and physiologic process. Phosphate levels in the blood are regulated by insulin-like growth factor 1 in addition to regulation by hormones of bone mineralization. Parathyroid hormone calcium feedback loop that controls calcium homeostasis. 4 organs, the parathyroid glands, intestine, kidney, and bone, together determine the parameters of calcium homeostasis. PTH binds to cell surface receptors in bone and kidney, thereby triggering responses that increase blood calcium. PTH also increases renal synthesis of calcitriol, the hormonally active form of vitamin D, which then acts on the intestine to augment absorption of dietary calcium, in addition to promoting calcium fluxes into blood from bone and kidney. Parathyroid hormone stimulates calcium reabsorption and inhibits phosphate transport in the kidney, as well as increases both bone formation and bone resorption. Calcitonin. Calcitonin is found in the non-follicular cells of the thyroid called C cells. Calcium stimulates the secretion of calcitonin that lower the blood calcium. Calcitonin in human disease. Calcitonin is secreted by several endocrine malignancies and therefore can serve as a tumor marker for medullary carcinoma of the thyroid. Abnormal basal and stimulated levels of calcitonin may be observed in patients on chronic hemodialysis. Calcitonin may also be ectopically secreted by insulinomas, lipomas, and lung cancers. Patients with severe bone inhalation injury, toxic shock syndrome, and pancreatitis may also have elevated calcitonin levels. Vitamin D. Nutritional supplementation of vitamin D is not required in humans who have adequate sun exposure. The cutaneous precursor of vitamin D, 7-hydrocholesterol, undergoes photochemical cleavage when exposed to ultraviolet irradiation. The resultant product, free vitamin D, is thermally labeled and undergoes a temperature-dependent molecular rearrangement that results in the production of vitamin D. In the liver, vitamin D undergoes 25-hydroxylation by a cytochrome P450-like enzyme. The final step in the production of the active hormone is the renal 1-alpha hydroxylation of calcidiol to calcitriol. Parathyroid hormone and hypophosphatemia are the major inducers of this enzyme, whereas calcium, calcitriol, and FGF23 repress it. Thanks for watching. If you enjoyed this video, just replay it. If you have any questions or suggestions, feel free to contact me through email. If there is the next episode, see you then!